Hi everybody. Now we're going to start working with the sine rule. The sine rule allows us to work with triangles other than right angle triangles, but it's based on the trig ratios, as was the area formula in the last video. So let's have a look. We're going to start with the triangle ABD, which is ABD, and we're going to define it in terms of sine. So sine of A will equal to opposite over hypotenuse, which gives us h over c. That's this equation here. Rearrange it to find h. H equals c sine A by multiplying both sides by c. Now we look at the triangle CBD, and we find out that sine c equals h over A. It's this equation here. So rearranging it to make h the subject, h equals A sine c. Now, since we have h in both equations, we're going to equate them together. So c sine A will equal to A sine c. Rearranging this equation by dividing both sides by c and then dividing both by A, we will end up with, sorry, that's not correct. Dividing both sides by sine A and dividing both sides by sine c, we'll end up with A divided by sine A equals c divided by sine c. Now, if we repeat that operation, instead of taking the perpendicular from B, take it from A instead, and repeat the same operation here, we'll end up with sine B on sine B equals C on sine C. Now, given we've got sine C in both cases, if we equate these two equations together, we find that A on sine A equals B on sine B, which gives us this expression here, where we know that A on sine A is equal to B on sine B is equal to C on sine C. And this is generally known as the sine rule. And if we want to state it in words, any side on the sine of the opposite angle is equal to the other side on the sine of its opposite angle. So this angle, this side divided by this, the sine of this angle is equal to this side divided by the sine of its angle is equal to this side divided by the sine of its angle. Let's have a look how that looks with a problem. So we have this angle and its opposite side. We have this angle and its opposite side. Given that we've got two sides and its opposite angles, it's indicating to us that it's a sine problem, or a sine rule problem. We can set up our equation. X divided by sine 70 is equal to 8.2 divided by sine 60. That's this here. We can put that into our calculator. I've rearranged it first this time to make it easier. And as long as our calculator is in degree mode, it'll punch out 8.89. If we're lazy and couldn't be bothered doing the rearranging, we can just put this equation here into our calculator. There it is there. It does require one extra step, in that you've got to type solve ans, x at the end to solve for x, and you get the same value. Either way is fine. Second case. So here we have not looking for a side but looking for an angle, and we've got to be careful with this because we know that sine has the ambiguous case, not just the acute angle but also the obtuse angles possible. We set it up the same. We've got a side and an opposite angle, a side and an opposite angle indicating it's the sine rule to use to solve for x. 7.1 on sine x is equal to 10.3 on sine 120. That's what we've got here. Put it into my calculator and said that I'm looking for all the angles between 0 and 180, because using sine it's possible to get obtuse angles, which gives me two values, 143 and 36.7. Now, in this case, it's not possible for x to be 143.3 because the angles in a triangle cannot be more than 180 degrees, and 143 plus 120 is more than 180 degrees. So the obtuse angle can be, well, it's not valid, can be ignored, and we're left with 36.7 being our solution. And over here I've put the reason why we've ignored it. Ignore the second obtuse angle, as the sum of the angles is greater than 180 degrees. And that finishes off example 4. If we look at example 5, we have been given a side and its opposite angle, and a side and its opposite angle, indicating to us this is a sine rule case. So 3.5 on sine 60 equals 4 on sine x. Stuck that into my calculator, solved it between 0 and 180, and gotten two answers out, 98.21 and 81.8. Add those to the angle that we've been given, and both of them are less than 180, so we have to include the ambiguous case in this example. It's a valid solution. Example 5b, we've been given angle x and its opposite side, angle 90 and its opposite side, indicating to us it's a sine rule case. I've set it up over here, don't think I have to explain it anymore. Solved it between 0 and 180, been given two angles, 135 and 44.6. 130 plus 50 is 185, which is more than 180 degrees. We can ignore that case, and only one of them is a valid solution, 44.6. If you've understood all of that, that's great. Have a try at exercise 1C, questions 1 to 10 only. To do the rest of exercise 1C, you need the cosine rule, which is in the next video. Thanks, everybody.